Hello, everyone. I'm Gary Berman from DevOps.com and the host of the Cyber Hero Adventure Show. It's a pleasure to welcome you to another great DevOps.com webinar. Today, we're going to learn about modern code analysis workflows for JavaScript. But before we get to today's presentation, let's go over a few housekeeping items. As you see, we use the GoToWebinar system, so for many of you, you'll see the control panel. Please just take a moment to click on the questions icon and the little downward arrow. This webinar is designed to be highly interactive with our great speaker today. We welcome your questions, comments, and suggestions in real time, and we'll get to as many as we can. If for some reason we're not able to get to your question, we'll email the replies to you shortly. Also, we'll be asking you some polling questions, and we'd really appreciate your thoughts. This webinar is being recorded, and the slides will be available to you on demand at DevOps.com in a couple of hours. Additionally, we have a giveaway of 4 $25 Amazon gift cards at the end of today's webinar, so stay tuned to see if you are one of the lucky winners. And now, a special thank you to our sponsor for today's webinar. Prabhu Subramanian is the lead product architect at ShiftLeft. Prabhu, take it away.
Thanks, Gary. That was a wonderful intro, and thank you everyone for joining. So we have a poll question for starters. If you could launch, Gary. Thank you. Please give some feedback. And what we tend to do is after this webinar, we will ask another poll question to see if the participants are changing their mind because of how wonderful my webinar was and so on. So I can see some votes coming up, which is awesome. And today's topic is very personal to me. Gary introduced me as the lead product architect for ShiftLeft. But prior to getting into application security, I was a JavaScript developer for over 10 years. So I kind of understand the challenges, the opportunities, pain points with building applications using JavaScript and various JavaScript frameworks and so on. But after getting into security industry, I started seeing JavaScript as a security analyst, as a static analysis tool author, the challenges and again the opportunities involved in automating security testing for JavaScript apps and so on. But because of this breadth of knowledge, when we started building JavaScript product as part of ShiftLeft platform, we made sure I was like personally satisfied with whatever we are producing. I was the customer number one, and that's how we tested and we rolled out this product. And yeah, I can see from the poll that like it's a tie between receiving quicker security feedback to developers and better workflows. Absolutely agree. Especially with JavaScript, we tend to use JavaScript for productivity, for the speed of delivery, and so on. So any time wasted waiting for feedback, especially security feedback, is kind of defeating the point on its own. So what I have is a very small agenda, but I will try to explain each of these points, obviously, in detail. So what I want to do is, before jumping into the product and giving a demo and so on, I want to talk about state of JavaScript, how the JavaScript as a language looks right now, how the JavaScript frameworks kind of looks, and then I will jump into discussing about code analysis tools, specifically for JavaScript and its framework, the state of the tools, the opportunities and challenges involved, and then I will finally dive into the JavaScript product of ShiftLeft. But we can make it interactive. So if you have any questions, I will keep checking the questions panel on GoToWebinar. So you can feel free to post the questions, and then we can either slow down or speed up depending on how it goes. So when we talk about JavaScript, it could mean different things depending on who we are. So for this talk, I want to focus on 3 personas, right? So I want to start with JavaScript from a developer perspective. And to be honest, nowadays everybody is DevOps because with JavaScript, we also tend to do the build pipelines, the deployments, everything. So it's full stack. So it's right to be called DevOps more than anything else. And then looking at JavaScript apps and then the security from a development manager, product owner perspective, as well as from an application security perspective. Uh, so the needs and wants of all these stakeholders are completely different. There could be some overlap, but the needs and wants are different. If we start with developers, so I mentioned Webpack. So Webpack is, for example, one of the complicated build chain available for JavaScript. It's very difficult to author Webpack configuration correctly, and then once we author it, the Webpack build sometimes is more than the npm install time. And then if you take npm install and Webpack build and all the optimization and tree shaking and so on, we are talking like 5 to 10 minutes here just on the build phase alone, right? So um, and then if you had like end-to-end tests on top of it, like just based test or the new Cypress tests and so on, there's already significant amount of waits and delays involved in building and testing JavaScript applications. And JavaScript, frankly, is not a language uh, that's very easy to pick up, easy to work with. We need to add something like Flow or TypeScript or a very good IDE on top of it to make the language usable for developers. And then when we look at application security, what happens is depending on the stage of DevSecOps in the organization, uh, we are seeing two different things. We are seeing application security people who are completely disconnected from the development, so they will be independent people completely away from the development team. They will be given this large piece of JavaScript code, which may or may not build, which could be using a framework and NPM packages the person may not have heard before. And then they will be asked to review this large monolithic piece in 1 or 2 days. Because if they ask for a week time, then the development manager or the product owner would wrongly classify AppSec as delaying the process or slowing down the velocity and so on, right? So application engineers, security engineers have a real problem properly testing and reviewing JavaScript applications. And it so turns out that when we did surveys, more than 90% simply do not bother. So they tend to use some kind of linting tools like ESLint, TSLint, or something with bunch of functional tests, unit tests. But when it comes to security, it's like not much is happening. So these are like challenges which, as a application security, cybersecurity company, we had a responsibility to address and take into account and so on. And from development manager, product owner perspective, two other things stood out. So for example, if a React developer goes to the product owner and says that to build this button, I have to build this React component, and then I have to use this Redux and Sagas and unit test and jest, and I need 2 weeks. And then the product owner sometimes wrongly assumes that, oh, it's just an HTML text field or it's just an HTML button. Why are you asking for 2 weeks? And there is a disconnect between the kind of challenges involved in building JavaScript applications, backend, frontend, even cloud applications, mobile applications, versus what people think is involved to build or secure or deploy and so on. And I said I'll start with state of JavaScript. And usually what happens is applications security company, cyber security company, they produce this yearly state of the market reports, right? So state of cloud security, state of application security, state of open source, and so on. But when we talk about JavaScript, 1 year is like too long. Like even 1 week is, I'm finding nowadays, is like a lot of things happening. So just last week, if you see, Node.js 15.0.1 came out. And 15.0.1 in fact fixed a critical vulnerability in Node.js 15. I'm sharing a screenshot here. So somebody messed up, so all the random values were just zeros, and like because it is zeros, you can easily predict the encrypted form of certain things and so on. Fortunately, it was fixed within 2 days, but it was crazy that a major release of a programming language had such security issue, right? But the good news is lots of cool things came out. A bunch of uh, new assignment forms came out. Like these are conditional or based assignments and based assignment. I'm not sure how many participants here had an opportunity to play with these new operators. There is also npm 7 with yarn compatibility. And then if you look at the front-end frameworks, we have new versions of React and Angular and Vue.js steadily coming out. And these are not just challenges for the developers and AppSec. These are actually challenges for even AppSec company like Shift Left, because we need to constantly keep in touch with what's happening, all the changes. Like literally this week, we rolled out support for these new operators for Node 15, because if we don't add them, then we cannot scan Node 15 application. So it's um, JavaScript already is dynamic enough. Like there is no fixed thing. Like you can have a variable request, but the same request variable can be misused to be used for some other purpose. So it's a completely dynamic language. The language is already giving enough challenges for code analysis tool authors, static analysis authors to do a proper job. On top of it, we have these npm packages and the never-ending flow of frameworks on a weekly basis, right? So state of JavaScript, it's kind of difficult for all of us, and I think it's something we need to openly accept. There is no magical bullet here. On the tool side, what we are seeing is, on one hand, we have these free open source tools. Okay, so um, we have tools that use what is called as regular expression based searches. There'll be a bunch of keyword based dictionaries looking for, say, eval um, or exec or spawn, and then the tool would spit out security violations saying do not use eval or do not use exec or so on, right? And then there are some tools that's like gradual improvements on top of it. These are grepping tools. They are glorifiedly called semantic grepping and so on. But it's a grep tool. End of the day, it supports more than simple regular expression based patterns and so on. Most of these tools are like they can pick up one or two good findings, but false positives, it's going to be a lot of findings, right? So if you have, for example, eval method used in a test code, then obviously we don't have to take that one as serious as an eval code that's used in a root, HTTP root, or eval function that's used along with a SQL or a NoSQL or a big data function and so on, right? We have what is called as abstract syntax tree, AST based linting tools, right? So like ESLint and TSLint. What these tools are good at is converting a single program into a syntax tree and then identifying some rules violations on this single file, like this camel casing is not good, or this same variable is used under two different data types, or this variable is not used, and so on. So we can write some simple rules using AST. But the moment we have imports, and like we have like 8 different styles of imports in JavaScript, right? We know that EJS, CJS, ESM. And whenever we mix and match imports and modules and defaults, and there are npm packages that could affect the global context and so on. So none of these linting tools can operate and work reliably. So as a security tool, they are not there yet. So we need an AppSec person. We need a real human to triage all the findings, identify the best ones from from false positives and so on, right? So this is on one side of the market. On the other side, we have these outrageous companies coming out with artificial intelligence, machine learning based tools, right? So in simple terms, the way how these modern artificial intelligence based tools work is they go through all GitHub, identify vulnerabilities for specific categories. So for example, in this case, path traversal vulnerability, they find say 10, 20, 100 instances of such vulnerability, train this algorithm with vulnerabilities with the hope that the moment we then start introducing new code, new projects, the algorithm would pick the vulnerabilities automatically, right? So hence it's like deep learning, deep kind of code. Unfortunately, it doesn't work like that in the real world. So this particular screenshot is something I found on the internet from a recent blog post. So if we see, there are a couple of terminologies we need to know when we are talking about security analysis. The first is called source, which is the source of the flow, where the attacker controlled flow starts in the program, right? So typically, HTTP creates server, that is the source. So that's where that is how we are starting a server, and that's how an attacker can gain entry into the program. And then we have request and response, which are potentially request is attacker controlled variable, right? And then sync is where the vulnerability ends, which is does the attacker controlled input gets sent back via HTTP, in which case it is a cross-site scripting attack, or does it go into the SQL database, in which case it's a SQL injection attack, no SQL injection attack, file write, remote code execution. So that's how it works. If you're hiring an AppSec engineer, these are basic questions you ask them. It's like what is the difference between let and const for AppSec engineers? It's so basic, right? This AI tool, for example, has put the source as request.url. Unfortunately, this is not the source, because the attacker could be using request.params, request.body, request.json. There's so many ways of injecting a vulnerable payload. So the source is create server, and the vulnerable parameter is request. So if you're hiring for a AppSec engineer, such a person will not even clear the interview. So and then the sync is wrongly assigned here, which is create read stream, but here you're just reading a file. It is the file stream.pipe, which is where the path traversal is happening, and the path is getting piped back to response. So this is the sync. So we can see that these artificial intelligence tools, to start with, is clearly not able to identify the sources and syncs, which are basic correctly, right? And then what happens is this move towards automatic remediation tips. Okay, this is a new thing which got popularized by these free dependency scanning tools, dependency bots, and so on. The idea is that if there is a vulnerability, they will tell you this open source package has this vulnerability, and then they will tell you, oh, if you just bump up this version number, the vulnerability will disappear, right? But I can promise you it's not as simple as that, right? There's no such thing as fixing vulnerability by just changing the package version number. This is because of various reasons. Firstly, to start with, to file a CVE is a time-consuming process. So if a security researcher identifies a vulnerability today, we are talking 3 to 6 months for even the CVE to get raised and published. And some CVEs like struts and all these Apache projects could take even longer, because there could be discussion. Somebody will say, I don't believe this is a vulnerability, or somebody will say, I need time to fix this vulnerability, and so on. So there is already a big piece of delay. And secondly, the fix version that gets agreed upon may not even fix the vulnerability completely. This is because when the security researchers files a ticket, they might add a test case, and the developer might have taken that test case to come up with a fix. And then once the CV goes out, people will find more test case where the issue arises, and then there'll be back and forth conversation. So if an organization is relying entirely on package version numbers to keep them safe, trust me, it's not going to work, right? Now let's come to this problem with artificial intelligence based remediation technique, right? So what this AI tool is thinking is, instead of using req.url, if the developer just puts this.req.url, and then instead of res, if they put this.res, the vulnerability would disappear, right? Again, it's not as simple as that. You cannot just put a this prefix and fix a vulnerability. An artificial intelligence tool will not know the difference between this dot self dot and so on. Whereas a serious AppSec engineer, a good JavaScript developer would know how to rewrite this piece of code to fix the code vulnerability, path traversal, or any vulnerability for that matter. So what usually happens is some of these features gets built by traditional apps companies, and then it becomes an expectation. Every customer, every client who is evaluating SaaS tools, they completely forget the fact that the primary objective of a SaaS tool is to identify and help developers write secure applications, and then they start focusing on such fancy features like automatic remediation or package version bumps and so on. That it's I don't think this field is there yet to replace good developers and good AppSec engineers, right? If we then quickly look at all the other tools available, we have on-prem tools, which is like which used to be super cool 10 years ago when we all had dedicated servers, when we all loved locking up our physical servers. But in this day and age, having an on-prem solution is like it's all the cons of on-prem and none of the gains of cloud, right? And I've heard stories where this with this IT person set up this AppSec product on-prem, went on vacation, and nobody knew how to turn it on, how to troubleshoot. Nobody was able to security scan the product, and so on. Like, why? I mean, we have cloud now. Why can't we use cloud? And then we have runtime agents. So Shift Left as a company, we started our journey with runtime agents. We built products around it. But what we found was static analysis phase is often the easiest and quickest phase because you get access to the source code. We can scan every line of source code during that phase. Whereas with runtime agent, the application has to be built, deployed, and then somebody has to run. They have to write end-to-end test cases simulating all button clicks, all text field, all the interactions, which is like a lot of work. So these runtime agents sound awesome, but to make it work properly is like too much work and too little gain, to be honest. And then we have bunch of SaaS QL tools. I don't want to mention any names, but the way these tools work is they take the raw source code to the cloud, right? And then we have data breach. Like we saw a data breach yesterday at a famous company. Last week we read about a data breach at another famous code analysis company, and so on. So we can at this point assume that data breaches are going to happen. Like it will happen to Shift Left. It will happen to anyone. There's no denying that. So the best form of defense is not to take any source code. So when I architect a product, when we build a product, we'll make sure no source code gets taken to the cloud service. So which then brings us to the NextGen SaaS tool, which is we do security analysis in the cloud because cloud gives us scalability, performance. But instead of taking the raw form of source code, how about we just build code properties? Like how about we just identify class names, method names, parameter names, types, dependencies, and so on. Only take that small subset of information to the cloud and then do security analysis on the metadata, right? So this is the idea our chief scientist Fabian started exploring 10 years ago. when he was a professor at a university, he came up with what is called as code properties graph, CPG, which is a superior form of um, the AST and CFG, all the representations of source code. With CPG, we can represent not only the properties of the source code, we can also represent the properties of the dependencies, the module level dependencies, program level dependencies, open source dependencies, and so on in a consistent format. And then we can use that information in the cloud to perform security analysis. Uh, let's say worst case shift left gets hacked, somebody steals all CPG. It is only going to have class names, method names, parameter names. So there's no way anybody can reverse engineer and identify the whole source code based on just the metadata alone. So it's completely secure. That's how we have designed our NextGen platform. So no code leaves the CA environment. The way we have architected shift left for all languages, in fact, not just JavaScript, is the code properties are generated in the build server, in the CI server, or if somebody is testing locally, then in their own machine, and it is only the code properties, which is the representation here, gets taken to the cloud, and we perform security analysis. And when we built the JavaScript product, the first requirement was we should not ask the customer to perform any npm install or webpack install or something. So our JavaScript product can operate on the source code even before bundling, even before build. And we support all CI and dev workflows. So there is no restriction, there is no lock-in. Like in order to use this product, you need to have this particular Git, this particular project management software, this particular subscription. No, it is completely flexible, completely open, and we can mix and match CI and workflows and so on. And we have features for not just developers, not for AppSec, but for all stakeholders. We really wanted to build this experience that's universal for everybody involved, every stakeholder involved in a typical JavaScript development lifecycle. Okay, so the benefit of CPG-based security analysis is, unlike the artificial intelligence example that I gave, we can actually do a proper job in identifying. To start with the sources and sinks. So we have the source here, attacker control variable, and then we have the sinks. We can also identify the open source dependencies, the built-in dependencies. We can also do a proper job in identifying event listeners when a particular event will get triggered. For example, if we do a random search for eval, for example, this function will get pointed out. But to trigger this eval, you need to have a particular event listener. So the post should be happening, and then the end of the post is when this event listener gets triggered, and so on. So our CPG based analyzer can exactly understand when a particular event or a callback function will get executed, and then it can do a proper security analysis like a trained expert, and so on. So in fact, one of the ways we test our product is by writing JavaScript applications, by using the tool for our own websites, for our own JavaScript backend. And yeah, we simply don't benchmark. We don't compare it against a competition to say whether this product works or not. We try to use it ourselves because that's the best form of knowing whether the tool actually works or not. And in fact, I will show some examples. I will show some snippets that are quite tricky, quite complex, that a real developer is required to understand, and then we can use the same snippet with the tool and then find out how the tool is performing, and so on. So what we can do is, I think I have a good idea on the poll, so it's closed. Maybe we can think about another poll question towards the end of the talk. But if you have any questions on these slides I've shown so far, please feel free to ask. I keep checking the the questions panel. We can make it a bit interactive and so on. So looks like there are no questions. So what I'm going to do is I'm going to demo the shift left JavaScript product with a sample application. It's called exploitable node application. This is a Node.js application. Maybe another webinar I will show shift left with a front-end framework like React or Angular and so on. So this particular application we have seeded with a number of vulnerabilities. So we have RCEs, NoSQL, SQL injection, XSS, and so on. Some of the code snippets might look artificial uh, because it's very unusual to have all of the vulnerabilities in a single app. But we'll do our best. We'll try to mimic what is possible and so on. And what I'm going to do now is I'm going to try using GitHub code spaces for the demo. But shift left as a product, like I said, supports all CI, all Git. There's no restriction. If code space works, we can use this for the demo. If not, I will switch to my local IDE, and then we can go through the product and the experience and so on. Okay, so I'm assuming everybody is able to see my code space with the README file. So this application has, like I said, bunch of vulnerabilities, and I'm going to start with what is called a sensitive data leak, which is one of my favorite. So what sensitive data leak means is the sensitive information such as the username, password, or the personal information like address, accounts, somebody's reservations, financial information, they're getting leaked in plain text, either in the log file or in Sentry logs or any Splunk logs and so on, right? What usually happens is when the sensitive data gets leaked to the log and then gets pushed to another uh, observable cloud monitoring service and so on, there is a big process involved in cleaning up all these leaked data. And with GDPR and all these regulations, it's a very time consuming, expensive process. People have lost their job for leaking sensitive information on the logs and so on. So the sooner we can detect these leaks during the development coding phase itself, the amount of time saved is massive, right? So what I have is a JavaScript file, sensitive.js, and this is an express.js file, and I have a bunch of roots here. To start with, there is a root called /greeting, and so this is getting username and password from the query, and it's unfortunately doing a console.log of password. So not good. And then in the second root, I have greeting2, where it's checking if the user is authenticated, and then still does console.log request.query.password. So even though there is like a if condition here, you it is leaking the password of the authenticated user. So it is a legitimate data leak. There is no question about that. This greeting3 root is getting the username and password, and then it's checking if the user is authenticated, and then it is constructing another data object, but unfortunately it is doing a console.log of the new variable with sensitive data in it. Not great. And lastly, we have greeting4 root, which is getting username and password. It is doing all these things, but it is creating another request variable with request.foo equal to bar, and then it does console.log of request, which is obviously a false positive because this request variable does not contain any sensitive information, right? So if you are using a regex-based tool to check whether console.log of password exists, it might pick this one it may not pick here, so we will add the regex to do more than password, and it won't obviously pick here because there is no password here, it is data. So we need a proper data flow tracking software to identify what this data object really contains, and we need to do it statically, uh, because yeah, like I said, we need to be able to detect vulnerabilities during the code analysis, coding phase, not after build and deploy and so on. And then if we have a regex tool that is like looking for REQ star, then obviously it will point to this false positive, right? So frankly, regex tool and all these grep tools simply cannot be used for security analysis. There's no way we can implement security rules with just lookups alone. We need a proper tool. Okay, now let's look at shift left. So this is how the NGSAS platform looks like. It's a cloud-based platform. If you look at the master branch, so I can see that there's like a lot of sensitive data leak here. And shift left is a proper data flow analysis platform. So what that means is we will correctly point out to the source of the vulnerability, unlike that AA example which cannot do these, and we will track the whole flow. We will say, okay, this is where the request object is coming in, and then this is where it's going through, and we will map out the complete vulnerability, so it's super easy for developers to understand where the vulnerability starts, where the vulnerability ends, and then we also provide useful tags and tips for developers to remediate the issues. And if you go through these findings, you would find that greeting 4 would not exist because, yeah, so if you see this root greeting 3 and then yeah, greeting, and yeah, I've done this so many times that yeah, so the tool will do a proper job of reviewing, analyzing the data flow like a real person, real AppSec engineer, and it can exactly know that this request variable does not contain any sensitive information or not. So how do we remediate this sensitive data leak, right? It's actually very easy. So what I have opted for is simply comment out all the console.log statements. So I have a separate branch for that on GitHub. Like I said, we support all Git providers, all CI platforms. I'm using GitHub out of convenience. Maybe for future webinars, I will mix and match GitLab, Bitbucket, and so on, so that we can understand the power of shift left platform. So what I have done is I've just commented out all the console.log, and I've not commented out this because it's not a thing I need to worry about anyway, right? And then we need to analyze the code. So shift left, like I said, supports a range of workflows. Sometimes I love analyzing the work as I go. So what I'm going to do here is, this is the master branch. I'm going to just analyze the master branch. We provide shift left CLI tool called SL, and SL accepts an analyze command, and then the application name. If you want to use a branch, we can use branch, and then the language, which is JS. CPG is code properties graph, and then dot is the current directory. So this is a live demo. So whatever time it takes now is the time I'm going to say the product would take. But like I said, we use this product when we build applications, when we deploy test applications. So if the shift left product takes time, then shift left as a company is not productive enough. It is not agile enough to deliver new features and so on. So this is how we tend to build and improve the product. There's no video, there's no faking or anything here. This is live. So what shift left CLI tool is now doing is it is converting the JavaScript code into what is called as code properties graph, which is just the metadata alone. And then it is just printing a useful summary. And then as you can see, the metadata alone is just 319 KB, and which gets pushed to the cloud for analysis. And that's it. So this is literally the time shift left takes to properly do a data flow analysis, security analysis for an application. For a million lines, a large application and so on, we are looking at 10 minutes, 15 minutes. In case of Java, we need time to build and package the application, which is the time taken by Maven and Gradle and so on. So there are some delays there, but shift left is the fastest security tool in the market. It's simply not possible to build a tool faster than this and claim to be a proper data flow analysis based security tool. It's not possible. And so what I have done here is, like I said, I have a branch called feature sensitive where I have commented out, and I have pre-scanned the branches. And as you can see, all the sensitive data leaks disappeared because I have remediated the vulnerabilities by commenting out the code and so on. So super easy, right? So let's look at another branch. So let's look at my favorite, prototype pollution. Okay, so prototype pollution is something we are seeing in every JavaScript projects, not just open source. We are seeing prototype pollution in even custom projects. But because static analysis tools simply suck at detecting prototype pollution, we see more prototype pollution getting raised against open source project, not at custom projects. Whereas with shift left, we can identify prototype pollution on all projects, right? So let's take this example. So we have REQ, and then there is a config object coming in from the request body, and then the object is being used with Lodash defaults deep, which unfortunately suffers from prototype pollution in this example. And so what's happening is when you pass such a string as a config value with constructor and prototype, this isAdmin value will go all the way to the config. So it will become config.isAdmin:true. So now this config variable is vulnerable. And then we have a get current user method, which is accepting this config value, which is not doing a good job. It's simply returning the same variable back. And then it is here. And then obviously user.isAdmin will succeed because the attacker has managed to pollute the prototype of config. And how do we fix this, right? So to start with, the developer consciously used Lodash.defaults deep because the Lodash is a decent library. It gives a bunch of tools. So the developer could have rewritten the functionality of defaults deep with for loops and so on themselves. But by using an open source package, there is an amount of risk somebody is taking in return for productivity and speeder rollout and deployments. So if there is prototype pollution vulnerability in Lodash, then we cannot blame the open source developer for that because we are consciously trading some risk in return for productivity. So it's a shared responsibility, right? And expecting Lodash to fix all the vulnerabilities is also not great. So when these dependency scanning tools tell us that if we update version numbers, the vulnerability will disappear, maybe a small vulnerability might disappear. Maybe one test case is getting improved, but it is not making the application secure. The application will get secure only if the developer writes proper secure code, right? This code can be improved definitely. So if we look at say the branch where I have tried some improvements. So what I'm going to do is I'm going to use the GitHub compare feature, which does a wonderful job in showing the differences compared to what I have here. So if you take this branch, so earlier it was just relying on Lodash defaults deep, and then we are relying on the open source project to do too much. We are relying on the open source tool to do validation and so on. Instead, we can do our own validation. Like we can write is this config object valid? And that validation function is simple, right? So firstly, if the object is empty, return false, or if the object has a key constructor, and if that is a function, return false, or if the object has proto as a key, return false, else return true. That's it. So this is how we write a validation function to guard against prototype pollution. And instead of writing this simple method, if we keep bumping up the version number, then how can we call that as security? How can we call that as secure code? That just doesn't make sense. So if we start writing proper code, then irrespective of whether we update the version, whether we use open source packages that are having monthly releases, daily releases, weekly releases, our application overall security will be improved. So I have tried a nice remediation. We can further improve this. Obviously, we can start checking the type, and we can have regular expressions for each and every properties and so on, depending on how much time we are willing to spend on a particular code, particular method. And after we do this, and then when we ask shift left to scan using the SL analyze command. So for example, on the master branch, there is a prototype pollution. Whereas if I go to feature A9, okay, maybe I have to scan it. Maybe I have to scan this application once again. But what will happen is we will find that the finding would disappear, because shift left code analysis platform would go through the whole data flow and then identify that suitable remediation has been performed, and then it will automatically remove the finding and so on. And I showed one example with using SL analyze command locally, but we tend to use shift left with the CI CD pipeline. And again, I'm showing an example with GitHub, but we support all CI providers. So the command to integrate shift left into CI/CD builds is SL analyze command followed by similar arguments. And we also have what is called as a check analysis command, which can do two things. It can look at the findings from the analysis, and we support range of build rules and policies and so on. And what this check analysis command can also do is do things like annotating the pull request. So if we look at a bunch of PRs I have got, so we will find that shift left can make some comments like this. It can give a total as well as giving the link, direct link to the analysis and so on. So this is like proper DevSecOps experience, where the same developer is also able to perform security tests, get security feedback quickly, and then better workflow integration into existing tools like existing IDEs, existing Git, existing CLI. There is no sophisticated setup process, tooling process involved. So we started with this poll question. I think we are nailing the product in terms of the expectation, which is quicker security feedback, better workflows, and so on. Lastly, if I quickly show how a build rule file would look, it's simple YAML. We can have an ID, we can specify the finding types, we can specify the severity types, and we can have the count threshold, which would trigger either the build to fail or pass and so on. And we support multiple such build rules. Depending on the branch syntax, we can also support build rules and policies. Depending on the application, depending on the organization, completely customizable. So the admin side of things is also properly taken care of, where a AppSec engineer or a CIO can come up with policies based on the threat radius, compliance, regulatory needs, and then they can tailor the security side of things. And shift left platform is extremely easy to use. So we offer unlimited scanning, unlimited concurrency. So there is just no limit on creativity, innovation. There's like no bottleneck. We have developers performing 100+ scans on the same day, especially when they are trying to fix security issues before a major rollout and stuff like that. They can try a range of fixes, and then they can try to see how the changes help or uh, improve the process and so on. And then we have reporting and compare and all these features that are expected nowadays from any tool. We can also detect secrets getting leaked, by the way. So we support a range of secrets. So we use a combination of regular expressions, entropies, and some clever secrets parsing rules to identify secrets and credentials. Maybe this application doesn't have, but so this is shift left platform. This is modern code analysis for JavaScript with shift left, and I'm happy to take any questions you might have.
Wow, that was incredibly interesting, and it's really impressive how Shift Left is distilling, very complicated matters into something that's, just kind of easy to use. How long does it take to get up to speed on the system?
It's extremely easy to roll out. So we have easy deployment tools for GitHub, for example. When anybody registers to shift left using the register link, we automatically help them set up their GitHub applications, and it's very easy to set up with GitHub. And we also have like automation deployment scripts for Azure, GitLab, and Bitbucket, and so on. So yeah, super simple to set up. The product would work out of the box even if somebody doesn't have time to configure the build rules and policies, because it all uses the same default settings that we at Shift Left internally use. So the product is completely usable. And the beauty is you don't have to call me or email any of us. You can just register and just get started. We need human interaction only if somebody is interested in enterprise accounts and so on. We also offer like a trial sign up, trial upgrade, and so on. So super simple to register and use.
Can you amplify a little further your remarks pertaining to the shared responsibility when using open source code in your system?
That's right. So basically, this is all about helping developers get more productive and start writing secure code. And there is an element of understanding that security is not something we can outsource to another tool and tell us when to upgrade a package, when to update a package to make our application secure. That's simply not possible, not a great thing to do. So with shift left, we help developers become very productive, good, secure developers. We show them vulnerabilities, we show them real data flows with sources and sinks. Our product is extremely accurate, because we tend to use real human experts to use and review and optimize and so on. So there's no false positives or raising security issues for the sake of it. And it really helps developers improve and learn from the tool and learn with the tool and become more productive. And it is built for organizations who are expecting their DevSecOps program, their AppSec program to be in this way. If I have had or heard horror stories where uh, softwares get picked as a checkbox, like does your company have a static analysis tool, and then they pick a vendor to satisfy some SOC requirement or a PCI requirement or something. So that's not helpful for anyone, even the developers and the vendors all as well. So that's not the model we should be looking at. We should be taking security is a joint responsibility. As a vendor, the vendor can provide certain expertise, certain automation capabilities, certain tooling, certain UIs, but and then there is an expectation from the organization to help their developers become mature, good developers, adopting modern workflows, modern best practices, and so on.
And can you share, with our audience, perhaps a use case where you've been able, by using your system, to reduce response time, reduce number of errors, that kind of thing?
Oh, so I can give you. In fact, almost all of our customers respond with similar statistics, with similar feedback, saying um, security tickets that used to get pushed onto Jira as backlog are now happily getting fixed in the same sprint, because our product is giving information way quicker, way sooner, with helpful data flows and tips that developers love fixing. They're starting to care about their product. So something like one of our largest customers said that 70% of the security findings got fixed within a week, whereas in the past, when they had used these legacy consumer brands, large AppSec vendors, developers did like 2 or 3 security scans per year, not per day, per week, per year. And
Wow.
most of these findings were hardly addressed because there's just a lot of false positives, and there's just complete lack of interest, motivation to take security seriously. So I think as a DevSecOps tool, we have nailed it. Another real example is shift left. When we went for SOC 2 audit, uh, we presented all of the shift left scan reports to our SOC 2 auditors, and our SOC 2 audit literally took 2 days compared to weeks or months, which is typically the time frame quoted
Wow.
out. So yeah, this tool is purpose built.
Yeah, terrific. We're going to go to the poll question now, as we're just wrapping up. And thank you so much. This is terrific.
My pleasure.
So the question is, are you looking to replace your existing static analysis tools? And there's, of course, no right or wrong answer. You can select yes or no. We're not sure. And while we're waiting for those responses, what other languages aside from JavaScript does shift left support?
Yes, on the deep analyzer, we support a number of languages. We support Java, C#. We also support TypeScript, Go. Uh, there's a number of languages. On the we also have like an open source free offering where we support more scripting configuration like languages and so on. So we have very good coverage.
Okay, terrific. And we should be getting the poll results in just a moment. There we go. And 32% said yes, 11 no, and quite a few of you are just not sure at this time.
That's awesome, isn't it? I mean, I would suggest everybody to try our free product, free trial. Even people, the 32% who really want to replace, I think the best approach would be to sign up, try it out, see if Shift Left is the right product for your team, for your needs. While I would love to say, oh, Shift Left is built for everybody, it should perform magic, but it could turn out that maybe uh, SAST is the least of the particular organization's concern at that point. So always try with the free account, try the premium trial. We are constantly available. I tend to do these webinars quite frequently, and we are also available on various channels. So have a chat with us, even if you're not sure um, whether tool will offer any benefits or not, and we are here to help.
Well, that's great. And just to wrap up, the winners of our $25 Amazon card are Mark K, Stella M, David R, and Sal P. So thanks again. This was just incredibly interesting to everyone. So for our winners, just so you know, someone from the DevOps team will be sending you an email to make sure that we get you the card. This webinar has been recorded. It's going to be available to you on demand at devops.com in a couple of hours. In the meantime, thank you so much for spending this time with us, and have a great day.
Thank you.